Hello everyone. Today we are going to be dealing with strength of materials and the stresses and strains and structures and mechanical components. Strength of materials is a field of engineering that focuses on the behavior of solid objects subject to stresses and strains. It involves the study of how materials deform, that is, stretch, compress, and twist, and fail under various types of loads. Understanding these properties is crucial for designing safe and efficient structures and machinery. There are a few key concepts under strength of materials. The first one is stress and strain, where stress is defined as the internal force per unit area within materials that arises from externally applied forces. It is measured in Pascal. We have two types of stress, and that is normal stress and shear stress. Normal stress refers to stress which is perpendicular to the surface, whereby shear stress refers to stress which is parallel to the surface. With strain, we are talking about the deformation or displacement of material in response to an applied stress. Just like with stress, we have two types of strain, which is normal strain and shear strain. Normal strain refers to the change in length divided by the original length, whereas shear strain refers to the change in angle between two lines originally perpendicular. Hooke's law. So with Hooke's law, it's stress being directly proportional to strain in elastic materials. Then we have Poisson's ratio, which is the ratio of transverse strain to axial strain in the material when it is stretched. With the modulus of elasticity, or Young's modulus, which is represented with the symbol E, it is a measure of the stiffness of a material, and higher values indicate stiffer materials. Shear modulus is a measure of the material's ability to resist shear deformation, and torsion refers to the twisting of an object due to an applied torque. The torsion equation relates the torque applied to a shaft with the shear stress and the polar moment of inertia. Those were a few key concepts under strength of materials. The next thing we are going to be focusing on is the stress strain curve, which you can see on the right side of the presentation. So the curve plots the relationship between stress, the amount of force applied per unit area, and strain, or the resulting deformation in material caused by that force. One key factor that can be determined from the stress strain curve is Young's modulus, which represents a material's stiffness or resistance to deformation. By analyzing the slope of the curve, engineers can gain insight into how likely a material is to fail under different loading conditions. Yield and ultimate strength are also important parameters that can be calculated from the stress strain curve. This concept is important and is as well essential for designing mechanical components and structures that will not fail under load. Now we are going to be talking about the failure theories. The maximum normal stress theory, also known as the Rankine theory, is a widely used theory of failure in the field of strength of materials. It states that failure occurs when the maximum normal stress in a material exceeds its ultimate tensile or compressive strength. The design of mechanical components and structures must consider the possibility of failure, making understanding the strength of materials critical. So while various failure theories exist, they all attempt to predict when a material or a structure will fall or fail under specific loads. So for that reason, designers and engineers must account for factors such as load distribution, material properties, and geometric constraints when designing mechanical components and structures that can withstand expected loads without. Let's look at the importance of strength of materials. So engineers must have a solid grasp of how different materials behave under various loads and stresses in order to ensure that their designs meet safety standards. By knowing the properties of materials, engineers can select appropriate materials for a specific application, which ensures safety and durability. They can also consider factors such as the shape and size of the component or structure, as well as any environmental factors that may impact its performance. Ultimately, thoroughly understanding the strength of materials is essential for creating successful designs. Basically, as long as you are an engineer or anyone who's working on any sort of building, you need to know the specific strength of the material being used for the project that you're working on in order to ensure that it's durable and the building does not collapse, in order to ensure that lives are saved. Case studies. So then case studies provide real-world examples of how an understanding of the strength of materials is crucial in designing mechanical components and structures. Whether it is a bridge, an aircraft, a machine part, or a building, both designers and engineers must select appropriate materials and sizes to ensure optimal performance and longevity. So, for example, when designing a bridge, engineers must determine the load capacity and stability by analyzing the stress and strain on various parts of the bridge. Similarly, when designing an aircraft component, knowledge of the strength of materials is necessary in order to ensure safety and durability, where in this case we are ensuring the safety of the passengers on the flight and the durability of the aircraft itself. So now these case studies demonstrate the importance of understanding the behavior of materials under different loads and stresses in creating efficient, durable, and cost-effective products. That brings me to the end of this presentation. Thank you so much.